So, kia ora koutou, ko Manaia tōku ingoa. I'm going to be talking about one of the chapters from my master's research, supervised by Joe Monks at the University of Otago and our previous speaker, Anne Shesselman. Mauri ora kia tātou katoa, ki te mihi kia tātou kua tai mai nei, e tū whakahihi ana hau ki runga I te whenua o ōku tūpuna no whakatāneo. Ko ka pūtarangi te maunga, ohini mataroa te awa, kauri tēnei no te iwi o Ngāti awa. Ko Ngāti Hokopū te hapu, tū tonu rā toku marae, whakapiri tangata, rā ko wairaka. So we know that many species rely on dispersal to seek new habitats in response to changing environmental conditions. But dispersal isn't only about covering physical distance, it's also about survival and successful establishment in these new habitats. Forest birds in Aotearoa can no longer disperse as easily as they once were able to. So when territorial species raise their young, the parents will kick their offspring out once they're able to fend for themselves. This is known as natal dispersal. But effective dispersal combines this physical act of moving to a new location with the ability to survive and reproduce in these new areas in the long term. So connectivity is really important for species dispersal and their movement with their physical environments. So structural connectivity describes just the physical attributes of the landscape. So the structure of the environment itself. However, functional connectivity combines the amount and quality of a given habitat in a landscape with its connection to surrounding habitats, as well as the behavioral responses to different landscape attributes. So functional connectivity is species specific. Every species is going to have a different distance that they're able to travel over open areas like pasture, different times that they'll be able or more or less able to travel through. So habitat corridors functionality depends on species-specific responses to these habitats and the gaps between them. So when is dispersal effective? When does it work? Dispersal from inside a fenced reserve and into the wider landscape can be classified as a spillover effect. So this describes when the benefits of a fenced reserve extend beyond the reserve's boundaries and into surrounding habitats. Dispersal can only happen when there are appropriate levels of connectivity between suitable habitats. Dispersal can only really be successful when individuals can, 1, establish breeding territories, and 2, safely produce offspring each year. So we used the kakaruwai, or the South Island robin, as a case study species for investigating dispersal and persistence in fragmented landscapes with high predator abundance. So both sexes of kakaruwai are territorial year-round and form monogamous pairs, with some exceptions, of course. So paired and unpaired males can be easily distinguished. Both will do the territorial breeding calls during the breeding season, but only paired males will also courtship feed their partners. In this way, the ratio of individuals in these categories provides a reliable index of population health. So Innes et al., in their review of movement and habitat connectivity for New Zealand forest birds, classified the kakaruwai as moderately gap-limited. And they are amongst 7 other species most in need of corridors or translocations to enable them to establish safely in new sites. So I use the name kakaruwai to refer to the South Island species. This is the name used by mana whenua around Otago, so Ngāi Tahu. The totowai is a name used for the North Island species, but I've also included lots of some examples of other names that have been used for the South Island variety. So the New Zealand robin, which includes both the North and South Island species, have the highest number of recorded name variants used by Māori across any bird species. So there's 34 different names used for these manu. But yeah, like I just said, I've used the name kakaruwai. So here's my study sites just outside of Ōtepoti, Dunedin. We can see the left one is Whakaehu, or Silver Stream Reserve. This is managed by Dunedin City Council. This one is one of only 2 remnant kakaruwai populations left on the whole east coast of the South Island. So east of the mountain range, there's Silverstream, and then there's Kaikoura, which is shown with the little red cross in the left-hand corner. So Silverstream is heavily impacted by predators like stoats, rats, possums, and feral cats. The Kanuka forest understory here is also really degraded by forest browsers like wild pigs, deer, and goats. There's been no consistent predator control at this site since 2017. As part of my wider master's project, I discovered that this population is basically locally extinct. Only a single female survived to the end of the 2022 breeding season. And this was despite over 130 hours of searching for females. I could only find one that survived to the end. This extremely skewed sex ratio was a direct result of intense nest predation, as only females incubate and defend their nests. So the other study site, Orokonui Eco Sanctuary, is 120 hectares. So in 2010, 25 adults were translocated from Whakeahu, from Silverstream, into Orokonui. And then a year later, another 20 were translocated, and that was a mix of both adults and juveniles. Besides from mice, this site has been eradicated of all invasive mammals. Historically, any kakaruwai living within the Orokonui Valley would have once been a part of the same Ōtepoti Dunedin population as those in Silverstream. For now, they are completely isolated. The kakaruwai populations here in Otago represent ideal case studies for a locally rare and threatened species with a neighbouring translocated population that can be used as a reference point for understanding population limitations prior to the arrival of mammalian predators. So we know that connectivity is important for species with low dispersal abilities, but we wanted to know for populations inside eco-sanctuaries, when they spill over out of the fence, or out of the sanctuary, are there habitats that they can reach? Are they suitable? And are they appropriately connected? Comprehensive connectivity ensures that suitable habitats are accessible for all species, regardless of their gap-crossing abilities. For a habitat to be suitable, there must be appropriate levels of predator suppression or total eradication. Otherwise, populations may start to decline as birds migrate from eco-sanctuaries that are safe into unsafe sites. So we wanted to know where the kakaruwai were going once they left their natal territories inside the eco-sanctuary, and more importantly, if they were able to persist and breed in these new areas. Our objective was to investigate if this translocated population was demonstrating effective dispersal or positive spillover. If the three projected outcomes shown here, first created by Pickrell's surveys, she started in 2018. I'll explain them a little bit more shortly. If these three outcomes could be met, then the population could be considered to have successfully established outside the eco-sanctuary. So here's a map showing the different levels of predator control and management around Orokonui. So the actual eco-sanctuary is shown by the red line here. The orange line shows the inner halo, where the Halo Project, a delivery partner of Predator Free Dunedin, started predator trapping in 2017. And the green line shows the wider Halo Project boundary after they expanded their target area. So the Halo Project started biodiversity outcome monitoring in 2018, using kakaruwai as indicator species. They also repeated this a year later in 2019. I completed an additional year of surveys in 2022. The 11 sites are shown here in blue. These sites were chosen to best capture a range of suitable kakaruwai habitat within the halo boundary, focusing on publicly accessible areas within the inner halo at first, where trapping activities were most concentrated. Appropriate habitats included native and exotic forests with closed, dense, evenly distributed canopies and ground that contained heavy leaf litter, which they used to forage. So in 2018, 5 sites were surveyed. In 2019, an additional 6 sites were added. And in 2022, I repeated the surveys at 11 sites. 1 was excluded as it was much too far away and didn't contain any birds. So each survey was done twice per year during the breeding season. This meant we could identify territorial calls from the males. Conducting these counts in autumn around fledging time might yield higher detection rates. However, the observed individuals would likely be juveniles in their exploratory dispersal phase rather than adults with more firmly established permanent territories. All the adult birds encountered in spring would have dispersed there during the previous autumn, having successfully navigated through a winter season already. So we can see in 2018 here, the sites, 3 of them contained resident birds during both survey periods, so twice per year. So the orange dots show locations where we detected male territorial calling, and I've just stuck up little pictures of kakaruwai to show which sites contained birds. By 2019, 7 more sites were added, but none of these contained resident birds during either survey period that year. However, the same 3 sites still had resident birds in it in slightly different areas. By 2022, we can see 4 more sites have been colonized for the first time. The original 3 sites, White Road, Estuary Track, and Mount Cargill, also still have resident birds. So we can see that Graham's Bush in the bottom left-hand corner, this one was nearly 3 kilometers away from the eco-sanctuary, yet it still contained quite a high number of birds during the survey. Even though it was far away, it contained ideal habitat and was well connected through corridors. So we can see here that the 3 positive spillover indicators were all met during the 2022 season. So like I said, 3 sites contain birds over every survey year. In 2018, there was an estimated 6 individuals identified across all sites. The following year, though none of the new sites that were added contained any birds, there was an estimated 13 individuals. And by the final survey year, this increased again to 23 individuals. In 2022, 4 new sites were also colonized for the first time. So before I go into the results of the model that we created, I'll just explain a bit about the categories that we used. So we classified them as either fully native or other, and other contains mixes of both native, exotic, and or plantation, so that some of the sites were pine plantation and we also had eucalypt. Then we categorized the connectivity of each site using aerial imagery to determine which of the sites could be accessed via unbroken habitat corridors. This didn't necessarily mean unbroken native habitat, just not over pasture or farmland. So Richard and Armstrong's 2010 study found that radio-tracked potowai, so the North Island robin, were unlikely to cross gaps in forest cover greater than 110 meters, with pasture acting as a significant dispersal barrier. So we don't have an equivalent result that we can use for the South Island kakaruwai, but we can assume that it's going to be quite a similar distance. So we can see here, modelling showed that the distance from the eco-sanctuary, habitat connectivity, and habitat type were all important in determining kakaruwai presence outside Orokonui. So only 2 survey years were included here, 2019 and 2022. That's just because the 2018 site contained, the 2018 surveys contained far fewer sites. So in areas of native habitat, the top 2 here, we can see that kakaruwai presence was slightly higher in connected habitats rather than in disconnected ones. So top right is connected, top left is sites that were disconnected. Regardless of habitat connectivity or type, the probability of kakaruwai presence reduced significantly from a distance of 1,500 meters from the eco-sanctuary. So that's where you can see the big slope starts to happen. It starts to drop off after about 1,500 meters, even though, like I said before, the Graham's Bush site, which was 3 kilometers away, still contained quite a few birds. So the observed increase in kakaruwai over the survey period is likely a result of intensified predator control, as well as increased juvenile recruitment from within this eco-sanctuary each year. As we can see here, the HALO project dramatically increased their trapping efforts over the duration of the study. However, it's important to interpret this information with caution, as these numbers reflect trap catches, as in the number of pests removed, rather than residual pest indices, which would indicate how many pests actually remain in the project area. It was also likely that more juveniles were leaving the eco-sanctuary each year and entering into the halo. No full population surveys inside the eco-sanctuary have happened since 2018, but it's pretty safe to say that the population is still expanding with no sign of it slowing down. So what do these results show us? This population seems to be successfully dispersing outside the eco-sanctuary, and not just leaving it, but establishing new territories and producing their own offspring. Without the contribution of heavy mammalian trapping and ongoing biodiversity monitoring, we may not be experiencing the same outcome. It's crucial that predator control continues in areas like this, where native species may be naive to invasive predators and would be missing many anti-predator behaviours. For successful spillover out of heavily managed reserves, there needs to be appropriate habitat for individuals to reach and conditions suitable for them to persist. Eco-sanctuaries have the potential to support populations of plants and animals that are vulnerable to mammalian pests, challenging assertions that they have limited value in broader landscape-level conservation. However, for eco-sanctuaries to provide these advantages, they cannot operate as isolated islands in an otherwise inhospitable landscape. The distance from the eco-sanctuary emerged as a strong predictor of kakaruwai presence. This highlights the significance of proximity to the eco-sanctuary's border and territorial establishment. Because juvenile kakaruwai tend to settle near adults with already established territories, dispersal and expansion into the landscape is slow. This limitation between patches can cause species with low dispersal distances, like the kakaruwai, to be absent in good quality habitats. This research serves as a unique case study for assessing avian population spillover out of a highly managed area. It underscores the significance of suitable habitat and connectivity in creating what can be referred to as a halo effect, wherein a population thrives within the initial target area and contributes to the broader landscape's biodiversity. This research can also be used as a model for studying a species' effective dispersal at a population level using species-specific targeted monitoring. This accounts for differences in detectability between sexes, as well as other potential behavioural factors which may influence the probability of detection. This information holds immense value for conservationists and translocation practitioners seeking effective strategies to reinforce species survival and biodiversity beyond eco-sanctuary borders. So I'd just like to quickly thank and acknowledge these people and their organisations for their contribution in making this research possible. So, kātiaki au konei, mori ora kia tātou katoa. Thank you very much.